Good evening in Asia, good afternoon in Europe, and good morning in North America. My name is Holger Zeltwanger, and I'd like to welcome you on behalf of the Program Committee of the International CAN Conference. It is the 17th International CAN Conference and the first digital one. The motto of this conference is From Classical CAN via CAN FD to CAN XL. This means 3 generations under one roof. Let's look first into the history if we're covering 3 generations. All started in February 1986 with the presentation of CAN on the Detroit conference of the SAE. Intel and Bosch jointly introduced the CAN protocol. And you see here the press release, and I was in those days an editor, and you can still see that the records are there. So it is a long time ago that CAN was presented. Just a brief history of the CAN protocols. In 1988, Bosch introduced the CAN 1.1 specification of CAN. 2 years later, that's what you all know, the CAN 2.0 specification was released. There are 2 different versions, A and B. 3 years later, ISO standardized the CAN protocol originally introduced by Bosch in the ISO 11898 standard, which is nowadays known as Classical CAN protocol. 10 years later, when I was the task force leader in ISO, we splitted the document into 2 parts. One part was dealing with the data link layer and the physical coding sublayer. And then the other part was for the physical medium access sublayers. Again, a couple of years later, in 2012, CAN FD was introduced by Bosch. It was the release of version 1.0. 3 years later, again 3 years later, ISO standardized the protocol in the ISO 11898-1 standard. And we have now 2021, and CIA will release very soon the 3rd generation of the CAN protocol, known also as CAN XL protocol. In the moment, I have the document on my table just for a final quality check within the CIA. And so it needs just a couple of days and weeks until I will have released the document. From the beginning of the CAN technology, there was an idea to have a commander-responder behavior. Commander-responder meant in old days master-slave. Already in 1992, the CAN SLIO was introduced. This is the serial link input-output device developed in those days by Philips Semiconductors. It was commercially not so successful. A couple of years later, the automotive industry was ready to go with a commander-responder protocol, and so they invented LIN 1.0. The specification was introduced by several OEMs in cooperation with some semiconductor manufacturers. Many years later, the Japanese industry introduced also a commander-responder network, which uses some elements of CAN and some elements of LIN. This was the CXPI, and this was first described in 2015 by the SAE. In 2016, the LIN protocol was at the end internationally standard by ISO. This means after 17 years of the first introduction. A little bit faster was CXPI, which was released as an ISO standard in 2020. And we are now developing a new standard, which is called CAN FD Lite, which is also commander-responder behavior specifying. And this will be released hopefully by end of this year in CIA 604-1. You see, commander-responder behavior on automotive network has a long history. But the hot topic of the 17th International CAN Conference is CAN-XL. CAN-XL provides new features, provides new challenges and new chances. There are 4 different papers related to CAN-XL lower layers, and we will start directly after my introduction with this in the physical layer, and Magnus Hell will talk about CAN-XL in the physical world. Then we're going into more details on the CAN network, on the CAN-XL protocol, as well as error detection capabilities and error detection, how we can do this with the CRC. There's also some papers which are related to CAN-FD. We have 4 of them, and we will have one of them today and the others in the following days. And mainly it is we're discussing how we can design network, how we can test networks with using CAN-FD, and how we can improve our system designs. Last but not least, there are also some papers which have not only relations to CAN-FD, but also to classical CAN. This is regarding the CAN to TSN Ethernet gateway development, as well as benchmarking of CAN systems using the physical layer for car, truck, and marine case studies. This is given by Christopher Quigley from Warwick. Security in CAN networks is a big topic. Maybe it's not that hot anymore because security has a long history. When I remember that when I was a little bit younger than now, in end of the 70s, I wrote the first articles about viruses in computers. But it took a long time until this was also a topic in embedded networks. However, in 2005, we already standardized a secured CAN interface for tachographs. Of course, the standard was not that properly done as it could be, because it were the early days of security. And nowadays we have withdrawn the standard. The first known or reported attack via a CAN interface was done in 2007. This was just remotely accessing or controlling the power window. In 2008, there was another ISO standard dealing with security. So we need the security for end-of-life activation of onboard pyrotechnical devices. These are airbags, which are then exploded by the network communication. Also, this standard is now under review because also this was not done that properly. In 2014, the AUTOSAR framework for secure onboard communication was introduced. And 3 years later, NXP introduced a CAN transceiver with security functions. In 2020, the ISO standardized the security access service for diagnostic purposes. This is for downloading software as well as to connect external tools in the garages. And 2021, hopefully, CIA will introduce the CAN-XL data link layer security protocol in the specification CIA 613-2. In the CAN conference, we have 3 papers related to CAN security. And this will be on the 17th of June, one session, starting with a recap of embedded security, achieving multi-level CAN security by completing available technologies. And last but not least, the CAN-XL made secure by Donietta Elshani from Infineon, introducing that what we are standardizing in CIA. The history of CAN higher layers is very long. We started in 1992 in the CIA to develop the CAN application layer specification and released this in the same year. In the same year, also the CAN calibration protocol was introduced by the company Kleinknecht, and it took a couple of years its business to calibrate electronic control units. In 1994, like mushrooms, popped up several higher layer protocols. You know, maybe SAE J939 used in commercial vehicles. You may know CIA 301, the CAN open application layer, which was originally developed within a European research project. DeviceNet by Alan Bradley, and then with the non-profit organization Open Device Net Vendor Association. And last but not least, Smart Distributed System by Honeywell, which has disappeared in the meantime. In 1998, ISO standardized the first higher layer protocol based on CAN. This was for the communication between truck and trailers. 1 year later, CIA already developed the CAN Open Safety Protocol, which was the first time to provide a standardized solution for functional safety on CAN. In 2003, the CCP protocol was used then as an XCP protocol by the Assam Association. In 2004, ISO standardized the ISO-TP transport protocol for diagnostic purposes, which I said already is now secured in 2022. The agriculture industry introduced in 2007 the ISO 11783 series, also known as ISOBUS, which is based on J939. The marine industry started in 2008 to standardize the NEMA 2000 protocol, which is also based on J939. And then there was a couple of years, nothing new to be reported on higher layers, just the normal additions to the specification, just minor changes. But in 2017, CIA released the CAN OpenFD application layer based on CAN FD communication. This year, SAE released the J939-22 document, which also provides a CAN FD based application layer. So that means the CAN FD communication is now released also in the higher layer protocols. In 2021, we will see additional higher layer specifications in relation to CAN XL, for example, the SDU type definition, which will be released maybe also in a couple of weeks or months. I do not claim on completeness. I'm sorry if I missed some of the important higher layer protocols, but you see the slide is already full. There are a lot of CAN Open related papers in this conference. Most of them are dealing with testing and with some engineering, like assigning a node ID or like to identify new layer setting services for CAN OpenFD. There are also other higher layer related papers in this conference. They are discussing how we can use CAN XL with higher layer protocols. Vector will introduce IP concepts on CAN XL, and we will also have a presentation on multi-PDU concepts for heterogeneous backbone networks. And I will also present something at the end of the conference. Mainly it is the modeling of CAN communication, and I will describe the standardized layer management options for CAN-based networks. Oh, I forgot something. A CAN conference or any conference needs a keynote address. I'm very happy that we could convince Carsten Schanzer from Volkswagen to provide a keynote speech with the title Future of CAN from Perspective of an OEM. It is very important to have him with a deep background in the development of CAN-FD, and that he will provide us some insight view into a car maker, how to use CAN in the past, today, and tomorrow. Last but not least, I like to bring to your attention the CIA CAN Coffee. This is at the end of each of the 4 iCC days. There's a 1-hour session scheduled where we can discuss openly any question you have, and also those which are related to the presentations today or on the other days, as well as any question or any contribution in respect to CAN technology. Also, I may take your attention that we have tomorrow some open meetings in the CIA. So to say, we want to show everyone what we are doing in our working groups. And please make use of that, because we need your feedback sometimes when we are developing things. In addition, on the 3rd and 4th day, there are some webinars in front of the iCC, which are free of charge, where people give you some detailed information about different topics. Look to the CIA website, and you can register still to this, and then you get the Zoom link to participate. I hope that every one of you is satisfied at the end of this conference with the provided information. If there are some critics, please let us know how we can improve. As I said, it's the first time that we make a digital conference, and we hope that anything works smoothly. What we don't know, if we have considered all eventual things which may happen. And there happens normally things which we have not considered. Thank you. Before we start the conference, and we will start sharply at 12:30, and so that we will have some additional information what is upcoming in the CIA. We have scheduled a meeting for a workshop for modeling CAN communication. The date will be announced recently, and I invite you to participate. This is something what will improve the description of CAN specifications from the lower layer to the higher layer. And we are using there as a basis the ISO 7498 documents, and we will describe service access points. And for those who like to participate in that, please indicate this to the CIA office so that we can invite you in time. This looks like an academic approach, however, it is not, because this is also for those which make educating services, and you can improve then your education services if you follow this kind of descriptions. Also, it makes it easier for us to have more appropriate standards and know how they relate to each other. This is one of the activities which we will start in this summer. Another activity is regarding firefighting trucks. We have also scheduled at the end of June a workshop for that, so that you can participate in this workshop if you are interested to standardize communication on the body application. There are some standards already available, but they are not completed. and we're now going to complete them using this for other body applications like the ladders, like the top control units, and so on. There's a third activity which we have in plan for this summer. This is regarding the 3.3 volt transceivers. There's a proposal how we can standardize this so that we can have really interchangeable transceivers using the 3.3 volt power supply, in particular in respect to CAN FD and the CAN SIC transceivers. All these activities are under development, and I personally do not know if we will find enough participants to develop those standards, but I hope that many of you will participate and contribute to that, so that we have at the end some new standards in the pipeline for, let's say, in 1 or 2 years to provide this to the community. As I said, tomorrow there are several groups scheduled, and you should maybe then go to these groups and participate in that in more detail.